Thank you for being here, everybody. My name is Yili from ECE department. Today I'm going to talk about the future trend in engineering. So basically I'll talk about the human movement engineering. This is the title of the talk and it's also the outline of the talk. So I'll first talk about the movement, and then I'll talk about the movement of the human beings, and then I'll talk about how to engineer the human movement into something that's implementable and practical. So I'm going to get used to this one. So first thing is that, what is movement? Movement is something that has the motion that changes with respect to the space and time. So why is it important? Because without motion, the world is a boring world, it's a silent world, it's nothing. Everybody is moving. In the past, we studied the movement of the machines, like the clock, the automobile, and all possible machines. But now in the future, we are going to focus on the humans. The study of humans themselves doesn't have a long history. Only a few hundred years ago, some pioneers like Da Vinci and others, they studied the human figures and the muscles in the human figures and try to produce better pictures or paintings. Why human being is important? Because we are human beings. And 100 years ago, actually, only until 100 years ago, actually I should say, we have the ability to capture the human motion. The first pioneer is this guy, Mayridge. At that time, there's no video, so we take a set of pictures. So he actually collected a huge collection of the human figures and in different motions. Of course, the athlete is one of the subjects. We want to study why they act so powerful, so strong, and others are so graceful. So that's the beginning of studying the human figure motion. Why study the human motion is important? Because we can see from this picture. Actually, what we see every day is in the visual space. When I say visual space, it means what we perceive others' motion. But actually, it relates to the motor space of others, of persons, of human beings. The motor space basically means the muscles and how they coordinate each other to make the body moving, either natural or abnormal. And actually, we can go a step forward to study the thing in the neural system. So by studying the motors, we can study why the neural system is more function or is just like a normal behavior. So that's why it's important to study from the appearance, the representation, and go all the way down to the reason, the origin of that generate all these motions. One important thing is the health. Public health, like University of Maryland just set up a school of public health, and like other schools, actually the research in public health is really important nowadays. For example, the Parkinson, I got a technical problem here because it doesn't install the Flash player, so I have to go back to the Explorer. So the Parkinson disease is basically for mainly for the aged people. They are moving abnormally, but they are not just random. I mean, you can perceive some patterns there. So from the point of signal processing view, it's basically you have another pattern. You sum them together, and then you perceive this motion. So we need to discover what's the stochastic process, what's the reason for generate this abnormal motion. So this is one important thing in the public health. The other thing is like humanoid robot. From the Star Wars R2-D2 and his companion to the nowadays, the Honda. Sorry, I got to do it again. Just my fault. Humanoid robot. So a humanoid robot is a robot that tries to act, move, and serve human like human. So it has the head, it has the body, it has the motion, it has all the things that human being has. All the joints you can perceive is moving. But the point is that so far, it's just from the mechanical and electrical engineering perspective. It doesn't go from the human perspective. So you can perceive it's not actually not a human being. It's moving, but it's not a human being. So the whole point of the humanoid robot is that to make it serve as perfect as a human being. And from studying the human being in engineering, we can actually put all kinds of knowledge in the engineering into this broad aspect. Like we can implement the hardware, the filters, all the things we learned from the engineering past 100 years so that we can make this thing more humanoid. I create a word, I think. So now let's go back to the engineering. Please go ahead. In the past 100 years, one of the hardcore engineering is the signal processing. When I talk about signal processing, I mean in the early age, the telegraph across the Pacific, across the Atlantic, across all around the world. This is the telegraph. It's basically from machine to machine. And later on, we have telephone. It's the first generation of telephone, I think. And later on, in the everyday, when we call Verizon, when we call the service companies, we actually have the speech recognition program that serves as a human-computer interaction. So we can forecast that in the possible future, basically, we will have more focus on the human being. So one important representation of the human being is the motion. So it's very good for electrical engineering to study the signals inside the human being. So far, basically, I finished my first part. Is talk about what I'm going to do and why it is important. But before we really go a step further, we need to know the representation of the signals and the data, the inputs we need to process. We can see from actually an intuitive way of the human being is we have the distance from one joint to the other. For each joint, we have a three-dimensional degree of freedom rotation. In computer graphics, they design a set of hierarchical structure to describe this human motion in every time frame. So one possible characterization is they have the BioVision format that capture all these things. So it's a skeletonization. You have the skeleton. And then you just do the texture mapping so that you can have a full body. So they did a lot in this thing. So what we can borrow from this community is that we use this format and consider the rotation. Rotation is just a degree. And then we consider the degree of change with respect to the time, we get a signal. So when we move, we measure all possible degree of freedoms, and we get a set of 1D signals. Then we change all the problem from the human motion to the knowledge we know. That's how to process the signals.